Okay, so we're going to look at solving some simple trig equations. We're going to solve some more complicated ones as we head into the next couple of chapters, but we're going to begin with pretty much simple trig equations. So I would say sine x equals 1/5 is a pretty simple trig equation. Looking for angles, and they're going to, at times they'll tell you, look for these solutions in a certain range, because for example the sine function goes on forever and ever. There are infinitely many angles that would have a sine of 1/5. So for now we're going to look at looking between 0 and 2 pi or 0, 360 depending on what measurement we're in, what units of measurement we're having. So suppose I want to find where the sine of x equals 1/5, what angles have a sine of 1/5 between 0 and 360. And what we're going to learn is at our calculator, we're going to use our inverse trig keys on our calculator as a tool to help us get these answers. So visually, here's my sine curve from 0 to 360. Here's 1/5. I can see I have two solutions. So one way to solve this would be to directly say, well, if the sine of x is 1/5, the sine inverse of 1/5 is x. And when I go in my calculator, making sure that I am in degree mode, because they've asked me to go from 0 to 360. In degree mode, sine inverse of 1/5 equals 11.5 degrees. So if I come up here in this diagram, that 11.5 is right here. And so one of my answers indeed is going to be 11.5 degrees. How do I get the other one heading out here? How am I going to get this one? Well, imagine I started here, I went up to 11.5. If I keep going around, I'm going to get another angle over here whose reference angle is 11.5. That angle will also have a sine of 1/5. How do I get the measure of this angle? Take this reference angle and subtract that reference angle from 180. That's going to give me this angle. So 180 minus that little reference angle that I've referenced with a dot is going to be the other angle. So 180 minus 11.5 is about 169.5 degrees. That's my second solution here. So here's another one. Let's work again. Note where they're asking us to solve, where our solutions can be. We're working in radians this time. So from 0 to 2 pi, 0 inclusive, excluding 2 pi, because if I get an answer of 0, well, 2 pi would be an answer 2. But they're going to just go at usually exclusive one or the other of the endpoints, and usually they'll do exclusive the 2 pi. So I want to solve 2 tan x equals -5. First step in is to set us up so that we can use our tan inverse tool in our calculator. Tan of x equals -5 halves, dividing both sides by 2. So I then going to go to my calculator, and tan inverse of -5 halves equals x. Now, tan inverse, let's remember, tan inverse is going to pick an angle in between -pi/2 and +pi/2 that has a tangent of this value. So I go to my calculator and I get tan inverse of -5/2 in radians, and let's see what gets spit out. And we get -1.19. Well, remember, tan inverse is a tool on our calculator. It's going to pick an angle between -pi/2 and +pi/2. That -1.19 is going to be somewhere down here in this quadrant, -1.19. We know that -pi/2 is about 1.57, so that's why I'm going to be down here short of 1.57. But it's asked me to pick angles between 0 and 2 pi. So I've got to use this 1.19, but think about getting that reference angle up here of 1.19, and that'll be between 0 and 2 pi. Now I want my tangent here to be negative. So with a reference angle of 1.19, if I go up here and go, okay, 1.19 up here, my tangent's going to be +5/2, so that's not going to be good. Where do I need to get in order to get that tangent to be negative? I got to go over into the second quadrant here. Would be the first place where I have a reference angle of 1.19. Where would be the other angle where I'm going to have a negative tangent? Not down in the third quadrant, because x and y are both negative, and negative over negative is positive, so I'd have to go all the way around and spin to the fourth quadrant with my reference angle of 1.19. 1.19. So I've used my calculator, again, the tan inverse tool, I've used my tan inverse tool to help me get a reference angle, the 1.19 radian reference angle, for me to set up to get these answers here. So how am I going to get this first angle? Well, if my reference angle is 1.19, what's this angle going to be? It's going to be pi minus 1.19. And if my reference angle over here now is 1.19, what's this angle going to be? It's going to be 2 pi minus 1.19. And I could take and get decimal approximations for those. So that's two types of problems, again, where your simple trig equations ask to solve in either radians or degrees, and you got to be careful and make sure, again, note for these problems, I am drawing and working with diagrams to answer the question. So the book's going to define for you what's called an angle of inclination of a line. So I put some lines up here. They define it to be the line is a measure between 0 and 180 degrees from the positive x-axis to the line. So, for example, up here on this one, positive x-axis to the line, my angle of inclination is going to be between 90 and 180. Positive x-axis to line, angle of inclination between 90 and 180. Now, what happens if I'm over here? If the positive x-axis to the line, well, the positive x-axis is over here. It's not even really associated with this line at all, even if I extend the line down. But imagine if I were to slide this line over to either this position or this position. Since these lines are parallel, all three perhaps could be parallel. If I slide this one over, positive x-axis to line, it's going to be, in this case, negative x-axis to line. So wherever your line is, if you need to slide it over to the left, if your x-intercept over here is a negative, slide it over, it's going to be that angle right here's your angle of inclination. Now, all these lines we can see have a slope that is negative. How about if our slope is positive in these cases down here? Again, the angle to the nearest x-axis, or the positive x-axis, angle formed if I go through the origin. If I have a positive x-intercept, angle of inclination is here. Imagine if I slid the line over so the x-intercept was negative, I'm still looking at that angle of inclination here. So that's what an angle of inclination is. How do they define it in terms of slope, or how can we relate this angle of inclination to the slope of a line? Next slide. So let's suppose we have a line with a positive slope, whether we go through the origin or not. And if we've got a positive slope here, we can see that our angle of inclination is going to be acute from 0 to 90. And I look and I can draw and form a right triangle here somehow, delta y over delta x, wherever I want to do that, delta y over delta x. And if I form that right triangle, wherever I form it, I chose to form it here, but even if I were to have formed it down here, let's say, this larger triangle, since these lines would be parallel and corresponding angles are congruent, that also will be theta. So if I look at either right triangle by SOHCAHTOA, right triangle trig, delta y over delta x is going to be the tangent of theta, and we know also that delta y over delta x is the slope. So the tangent of that angle of inclination for this angle with positive slope, the tangent of the angle of inclination is the slope of the line. So what happens if our line has a negative slope here? We know our slope is negative. If we want to use this angle of inclination and the tangent of the angle of inclination being equal to that slope, here's what we can do. On our line, just create some arbitrary delta y over delta x, which is going to be your slope. I'm going to choose to create it right here. Note that if this is theta, our angle of inclination, and if our line has a negative slope, our angle of inclination is going to be from 90 to 180 with that x-axis. Note right here that this angle is going to be 180 minus theta. And since these lines are parallel, this angle down here is also going to be 180 minus theta. And I then could say and look at then the tangent of 180 minus theta, and that's going to be an acute angle. That angle is going to be between somewhere from 0 to 90. The tangent of 180 minus theta is going to be delta y over delta x. And note delta y over delta x, in this case, if I'm looking at distances, delta y over delta x is going to be positive. So the tangent of this acute angle is going to be positive. And clearly, if we think about an angle in standard position, if I have some acute angle, wherever it happens to be, is the tangent always going to be positive? Sure, because my x and y's in the first quadrant are always positive. So, the tangent of the supplement of our angle of inclination is going to be a positive number. It'll be delta y over delta x. How does that compare to the tangent of theta? Remember, positive number, and our slope we want to be negative, so we can take the opposite of delta y over delta x. But is it going to turn out that the tangent of theta is going to be the opposite of the tangent of 180 minus theta? Let's check that out. So let's remember that our theta, our angle of inclination, was obtuse angle to make our line have a negative slope, and then that made our 180 minus theta, the supplement, to be at acute angle, and we noted that the tangent of an acute angle is going to be positive. And let's take a look at this angle here. This angle is going to have a reference angle of 180 minus theta. This angle, being in the second quadrant, is going to have a negative x coordinate and a positive y coordinate. The tangent will be negative. And from the reference angle principle, what's the tangent of theta relative to the tangent of 180 minus theta? They're going to be the same, except they'll differ only in sign. For example, if I had the point here, negative a comma b, I know that on that 180 minus theta reference angle, I'm going to have a comma b. So indeed, if we have a angle of inclination that is greater than 90, the tangent of that angle is going to turn out to be a negative number, and it's going to turn out to be the slope of our line. Now an example. Suppose I'm told that I have an angle of inclination, my angle of inclination of my line is 112, and the line goes through 2, negative 7. First thing I'm going to do is draw a picture and go where 2, negative 7 is. If my angle of inclination is, again, obtuse, somewhere between 90 and 180, I know that line is going to have a negative slope. So, here's my angle of inclination. So what I'm going to do is I'm going to pretend that the line goes through 0, 0, parallel to my given line, and then I'm simply going to take that line, and I know that I'm going to move it right 2 and down 7, right 2, down 7, right 2, and down 7. So let's work with an angle of inclination through 0, 0. My angle of inclination 112 going through 0, 0, and then simply move that line, keeping it parallel, and move it down to 2, negative 7, passing through 2, negative 7. So, tangent of 112 is negative 2.47. So I know my slope is negative 2.47 for my line, and we said it went through 2, negative 7. So take this line, which would be y equals negative 2.47x, move it right 2, down 7, so y plus 7 equals negative 2.47x minus 2. So there's a line that goes through 2, negative 7 and has an angle of inclination of 112 degrees.